Hi everyone, welcome to Oracle Database Programming Section 8. We're going to be discussing grouping functions, but in this case we're going to start by doing it without using a clause called group by. That'll be covered in Section 9. So what we're really going to be looking at today is going to be different ways to use what we call statistical or aggregate functions. So let's take a look. So let's say we're taking a look at our roster table here. And we see we have a bunch of players and so on. And maybe we want to see something that is not just the information, but information about the information. So just to kind of throw it out there, let's say I wanted to see an average of the jersey number. I don't know, silly little example for the moment, but let's start with that. We can use statistical functions such as average, min, max, and so on. You can see the average is 50, which is actually pretty funny. There are going to be other examples here. We can use min to get the lowest. We see 0, which I believe is Brian Burns, and max. We have somebody wearing 99. I don't know who that is. Maybe DJ Davidson. But you can use these statistical functions to tell how many of those exist in our roster. So you can use them together as well. So I wanted to say, and of course we could rename this. We can go in and say max and min of jersey number. And you might do this if you're preparing a report for someone. Put these together. And you can see we have one column showing the maximum and one showing the minimum. So this might be a way for us to gather some sort of information about our tables. So we also have the ability to do a count. Now I'm going to show you just a quick little nuance with that, and then we'll take a look at a couple more examples. So we also count. We'll take a look at this a little further in a few minutes, but notice that we have the ability to go there and say count, and you have the ability to say, do I want to count number of rows or do I want to count values? So notice if I say count star, for our roster we see 78 players showing up. If I were to go in there and say count, let's say the jersey number, we'll see that it also shows 78, which makes sense. But if we count the date of birth, we're going to see that shows up with 77. And you might say to yourself, well, that doesn't make sense. Why would it do that? And if we were to take a look at our data, we would find that there is one player who has no date of birth or null date of birth. So this becomes a big issue a lot of times, determining what to do with null values when you're doing these types of statistical or what we call aggregate functions. Do you want to include them? Do you not want to include them? It's a big sticking point a lot of time. But generally what you'd find is that count star would include any rows, even if there are null values. Counting a field will count the number of values that exist that are non-null. So in the case of something like a date of birth, where there was one player with a null date of birth, they don't get counted because there is no value there. So it's counting how many values are there. So just to take a look at that, we'll see one of the players, let me bump this up, go up a little further than that. One of the players did have a null, there he is, TJ Moore. We have a null date of birth for TJ Moore, so therefore that's why that came back as 77 rather than 78. So let's take a look at our songs table for a moment. And this way we can do a little more with some of our functions. So notice that we have a few fields like duration, plays, likes, and skips that we can go in and get aggregate functions about. So we could go in and say sum duration, and this would show us how many total seconds there are in our database. So we see 20,000 seconds is going to be how many seconds make this up. We can also, again, very similar to our last example, do the max and maybe the min. We can see that means the longest song in there is 482 seconds. The shortest is 125 seconds. So it shows you there's quite a bit of difference there. Now there's two others that are mentioned. They're not very commonly used because traditionally we as a database folks, we're sending the data to other people to analyze. But we also have standard deviation, and we have variance. These are statistical functions just to determine how, a lot of times how choppy the data is. For example, you can have a test and every single student gets a 75 and the average is a 75. You can have that another test where half the class gets hundreds, half the class gets 50s, the average is still a 75. So sometimes you want to look a little deeper at some of those, like how much of a swing is there from student to student, and these can help you do that. And we can see that it shows that we have a pretty high variance and a decent amount of a standard deviation from our average or from our mean. I don't mean to minimize these, but you know, realistically, people are really mostly looking for sum, min, max, and average. So now this doesn't only apply to numeric fields for all of them. So for example, if you say max duration, you would expect to get a number, but let's take a look at another field that maybe is not numeric. Let's take a look at genre. Now this maybe verbally doesn't make sense, but you can see it does run. Now, how does it calculate maximum? And maybe when I do a minimum, it's going to give you a little extra clue. Notice that the minimum is the one starting with the lowest letter, C, and the maximum is the one starting with the highest letter. So it can be used for things like, you know, text fields, although you want to be very careful with that and make sure it's actually doing what you think it's doing. But if it is text-based fields, you can also use minimum, maximum. You can't use an average or standard deviation. And of course, you can use count. And just to show one more, in our roster, we also have the date of birth. And you can see date of birth there. So minimum, maximum not only apply to text and numbers, but they also can apply to the date of birth as well, or any date-based field. And we can see the oldest player on the team was born there. The youngest player was born there. And this would probably lead me down a little rabbit hole. Oh, I wonder who that was. And what I would think, if I didn't know that this isn't going to work, what I would think I would do is, oh, well, let's just do this. Select star from roster where date of birth equals min date of birth. And you'll see that we're going to get an error there. Grouping functions cannot show up as part of the where clause. Now, there are going to be ways for us to do this, but traditionally that's going to involve something called a subquery, which is going to be, I think, 2 sections ahead of us, section 10. So just keep that in mind. This would be handy to do, but just because of the way that Oracle and SQL in general order their operations, this can't be done this way. So even though you'd like to see that, you're not going to be able to do it easily like this. Back to our roster, if we take a look at our positions and we say count them, there are 78 positions showing up in this query. Now, there's not going to be 78 different positions that players are playing, right? You know, not everybody has a unique position. So when we use something like a count, what that is doing is it's not counting how many individual distinct values there are. You see there's multiple people who play running back. When we do a count, it is simply counting the number of values that appear. So if we do this and we get that 78, that's because there's 78 values. But we do have the ability to tell it to count how many distinct values appear, and we would be able to use our keyword distinct to do that. And in this case, this will tell us probably about 15 or so, 19 different positions. So that would tell you there are 19 different position groups, such as, okay, you have kickers, you have punters, and all these other football-y things. But this would be a way for us to count that. So let's move on to something using another field. So let's take a look at our date of birth. We see that we have 77 values. Now, what if we wanted to find out if any players on the team had the same birthday? Not just, they're born on the same, like March 2nd or whatever. They're born on literally the same day, same year, same everything. So we can do that and figure that out pretty easily by running this query. So if we count distinct date of birth, that'll tell you how many different values there are in our database. And we can see right now, as you might expect, 77 players. You wouldn't expect too many duplicates there. Now, as a final example, I had to make a change to our data to allow this to work. I've set the duration to null for one of the songs in our database, just so we can see the need for something I'm about to do here. If we were to say, let's select the average duration from songs, we're going to get this number. However, this number does not take into account that null value. What would we do if we wanted to get, we wanted to do something with that? If you remember the NVL command, it allowed us to do one thing if the value is null and one thing if the value is not. We could also do something like this. We could go in and say, select average, and we would say NVL duration, comma 0. So let's take a moment to look at what this is saying. So if the average wasn't there, this would say select the NVL with donation or 0. So let's just run that real quick, and we'll put it back into our query. So you can see for the first song, it displays 0. So what that basically does is it replaces any null values with 0, because 0 can then be averaged. So now if we do this, we are no longer getting the average of the duration. We are getting the average of this operation. We're doing the NVL of the duration, but if it's not there, we fill in a number 0. And I'll need a second close parenthesis there. But this should give us slightly different numbers. The one on the right will be slightly lower because we're throwing in an extra value that's 0. So we go from 252.9 to 249.7 there. So there may be times where you need to include null values as part of your queries. You might have null values and you might want to direct your SQL query to do something with those null values. So that's one other point that we can make, is that it doesn't just have to be a field here. It can also be another operation. And if you've done other programming classes, you may have heard the term nested functions, where you have one function inside of another. And that's exactly what we're looking at here. It's just two nested functions. So hopefully this helps with section 8, and take care.